Kuzzangpo, welcome to Bhutan e-learning program. This lesson is science lesson for Key Stage 3, that is for classes 7 and 8. I am Binod, teacher at Changaha Middle Secondary School. Now let's begin our lesson by looking at some of the pictures here and trying to guess the topic for the day. So we can see a person there trying to carry a bag of water there. We see some people working on the railway tracks. We can see some laborers trying to dig. We can see some kind of energy or light bulb there as well. Does this help you all guess the topic? Let's see if you have guessed it correctly or not. So the topic for the day is going to be work, power, and energy. These are the three topics we are going to discuss in our lesson today. But I also have some expectations from you. What do I expect from you? By the end of the lesson, you should be able to explain work. Relate work, force, and displacement. How are these three related to each other? You should know that one. Define power. Define energy. And finally, you all should be able to classify different forms of energy here. To begin with, let's recollect two terms, that is force and displacement. Can you recall? What does it mean by force and displacement to you? Now to help you, say for example you're asked to move a table. In how many ways will you be able to move a table? Or you can think of some other things in your daily lives which you move. Say for example, closing and opening of the door, or closing and opening of the window, or you are tidying up your study table, lifting your books and arranging them. Now in all of these cases, how are you doing it? How are you able to move the things there? The answer is, it is either a push or a pull there. You are moving things either by pushing it or by pulling it. So two things. A simple definition of our force here is, a force is a push or a pull there. So that is the definition of our force. Let's move into our displacement now. So we have a figure there. Say that point A is your house and point B is your friend's house. Now you want to go to your friend's house and you are taking the route, you are traveling from A to C, and from C you are going to D, and from D you are going to B. That is the route you have taken to reach to your friend's house there. Now that becomes the actual path which you have taken there to reach to your friend's place. Now if you can see a blue line there, or the arrow connecting point A and B, that is the displacement there. How we define it? Displacement is the shortest distance between any 2 points. That means it is the shortest distance between the initial point, that is the starting point, and then the final point. Okay? So displacement here is the shortest distance between two places. So I hope you all are clear about displacement. Now what is work? What comes to your mind? Is it that you are sitting there and waiting for you to get homework and do it? So doing homework is work to you? Or is it that you visualize or picture somebody sitting on a chair and working on the computer? That's work for you? Or is it that there is somebody working in the kitchen? That is work for you? Is it so? Yes, in general or daily term use of work, it's correct. A work for me right now is to teach you all this lesson on work, power, and energy right now. But in science, the definition of work is very different. Definition of work in science involves these two words which we just looked moments ago, that is force and displacement. So how is it defined? How is work defined in terms of science? Let's see there. Work is said to be done when a force acting on a body produces displacement. So when a force is acting on a body, it is able to displace it from its initial position. Then only we say work is done. So for example, we have here a boy. He's trying to pull his backpack, which is kept on the cart there. So as he moves forward, he will be pulling the cart along with him. He will be doing work there. So from the definition of work, which is a force acting on a body produces a displacement, we have the relation between work, force and displacement, which is already given there. Work done is equal to force times displacement. From the definition again, we come to a triangle law. Remember this triangle law. It will be very easy for you to remember the relation between work, force and displacement. Now if you are to calculate your work done from this triangle law, you have force times the displacement. Now if you want to find work done, that is W, you simply have to multiply force and displacement. So remember this here, the sign in between these two letters F and D here, you keep it as multiplication sign there. So work is F times D. If you are to calculate force when work done and displacement is given, so you are going to find out force. So force is equal to, we have work done here and below you have is the displacement. So which means your formula is going to be work done over displacement. Second. Now third, if you are to calculate displacement given work done and force, so we are going to find displacement D here is equal to, now work done is above and your force is below. So your relation becomes work done over force. Remembering this triangle law is very important and useful to you all. So you will be able to calculate them. So here it is division, here also it is division. So if you are finding force, work done divided by displacement. If you are finding displacement, work done divided by force. That is how you remember your triangle law. It will be much easier for you. Now, next move into the units of work. So when we are calculating some amount of work done, in what unit it is measured, we need to know that. So unit of work done, it is measured in terms of joule. So how do we get joules here? Again, so we will strike off these two, we will just keep one. Work done is equals force times displacement. Now the unit of force is Newton and unit of displacement is meter. So our unit for work done becomes Newton meter. 1 Newton meter is equals to 1 joules or 1 joule. So 1 Newton meter is equals to 1 joule, which means that the SI unit of work done is joule. Okay, that becomes the unit of work done. Interesting part again here is the calculation. For doing this, so almost all the information will be given there. You just have to remember the formula. So let's see. If a force of 10 Newton acting on a body produces a displacement of 0.3 meter, what will be the work done here? Now for example, say this object which is in my hand, I keep it here, I'm holding it here at the moment here. Do you think I'm doing work here? The answer is no. There is no displacement here. Now I'll lift this object to this height here. Is the work done here? Did I do any work here? In this case, I have done work. Now let's say in lifting this object here from its initial position to the new position here, I have applied 10 Newton force and I have displaced it, or I have moved it by 0.3 meter, that is 30 centimeter here. What will be the work done here? To calculate that one, let's come back to the formula here. Work done is equals to force times displacement. Force we have is 10 Newton times, what is the displacement? 0.3 meter. So our answer is going to be 10 into 0.3. It's going to be 3 Newton meter, which is equals to 3 joules. Since 1 Newton meter is equals to 1 joule. So here our work done is 3 joules. I have done 3 joules of work in lifting this object from its initial position to a height of 0.3 meter. So that is what we have there in the calculations as well. Okay. Now moving on to power. What comes to your mind when you see this word power? The superheroes. So let's see, how do we define power in science? Power is the rate of doing work. How fast you do a given work to you is power. So let's take an example. Say there are two persons, person A and person B. These two people are asked to stack or pile up 10 boxes of apple, say each weighing 10 kg. Okay, they're asked to stack up or pile up 10 boxes of carton here of apple. So we have carton box here, 10 kg each. So now, like this box, there are 10 boxes. So these two people, they are having, person A is asked to stack up 10 boxes of apple weighing 10 kg each. Similarly, B is also asked to do the same, to stack up 10 boxes of apple weighing 10 kg each. Now say he takes 2 minutes. 2 minutes to pile up. He's stacking it up and he takes 2 minutes. Person B takes here his time. Let's say he takes 3 minutes. He takes 3 minutes to do the same amount of work. Now in this case, who is doing the work faster? Person A. He is taking only 2 minutes here, while B is taking 3 minutes. His rate of doing work is faster than the person B here. So we say that his power, his rate of doing work here is greater than person B here. Power here is a measure of how quickly a work is being done. Okay? From the definition, we come to a relation between power, work, and time taken as P equals to W divided by T, where we have P is the power, W is the work done, and T is the time taken. All right. Next we have is the unit of power. Here the unit of power is watt. So how do we get that? Again, we go back to the relation power is equals to work done divided by time. So now, what is the unit of work done? Moments ago, we just saw that unit of work done is joules, represented by the letter J there. And what is the unit of time? Seconds. So the unit of power is joules per second or This joules per second is also known as watt. W-A-T-T, watt. So watt is the unit of power, not W-H-A-T, but it is W-A-T-T, watt. Okay, so it's also represented by the letter W there. So that is the unit of power. All right, let's move on to our next topic, energy. Yes, what comes to your mind when you talk about energy? What do you see there? A person trying to lift a weight, somebody running with a ball, some people working there on the railway track, somebody trying to ride a bicycle there. So what is energy here? I need energy here at the moment to speak to you all. So what is energy? It is the ability to do work. Very simple, isn't it? It is the ability to do work. We need energy to do our daily activities. And where do we get this energy from? The food that we eat, isn't it? Taking food on time is important here. Next we have is forms of energy. Let's look into some of the different forms of energy which we have already come across, which you might already be knowing. Let's recollect those. Maybe kinetic energy, potential energy. Let's see, the list will go on. So first what we have, light energy. What do we have? It is the sound energy, kinetic energy, potential energy, electrical energy. So we are going to look into these 5 different forms of energy here. So let's take a look one by one. First thing, potential energy. What do you think by looking at the diagram or the picture given there? You see a hammer raised to a certain height and there is a nail below it. This hammer, when it is raised to a certain height, possesses energy. That it possesses a stored energy. So this stored energy is known as the potential energy. Now why do we say that? Because on releasing the hammer will be able to do some work on the nail. It will be able to drive the nail into the wood, isn't it? That is why we say potential energy is the stored energy, or potential energy is due to position, height, isn't it? When it is raised to a height, it has some stored energy in it, which will be able to do some work. That is why potential energy is the energy due to position. Let's look at some more examples. We see a girl with a ball on her hand at certain height. That ball possesses potential energy because it will be able to do some work. Potential energy is an energy due to position. Let's look at kinetic energy now. What do you think is kinetic energy? The first figure, it possesses potential energy. Now the second figure, the arrow is released. The arrow possesses kinetic energy there. What is kinetic energy here? Kinetic energy here is energy possessed by a moving body. When a body is set into motion, the body will possess kinetic energy because it will be able to do some work. Now, for example, I have a chalk in my hand. If I throw this chalk to somebody and it hits that person there, the person will feel the pain. Why? That's because this chalk, while it strikes that person there, it possesses energy in it when it is in flight. On striking the person will feel the pain because of the energy possessed by the chalk when in flight. Okay? Kinetic energy is energy possessed by a moving body. You can see some examples there. The dog is on the run, it will possess kinetic energy. The person holding a ball there, he's running, he also possesses kinetic energy. So these are some examples of kinetic energy. What do you think is this? This is light energy here. What does this light energy do to us? This light energy enables us to see things during daytime. Because of the sun, we are able to see things around us. During nighttime, we have the lights at home to light our home and make things visible to us. We are able to watch television or movies. It's all because of the light, reflected light. We are able to see things. So what do light energy do? It enables us to see things. Next, what do you think here? People, family are enjoying watching television. There are stock of edible items in the fridge. There is a laptop or a computer there. How is it possible for everything to run? Because of the electricity, yes, electrical energy now. This electrical energy enables or makes our life more comfortable. Now at this time of our life, 21st century, we have become so much dependent on electricity that we cannot imagine our life without it. Okay? You are feeling bored, you can put on your television and watch movies there. You want to do work, stay at home, work on your computer. You are feeling hot, you want to drink something cold, open your fridge, refrigerator, take something to drink from there. Our life is much more comfortable because of this electrical energy. Use electricity wisely. Okay? Now what do you see here? You can see a guitar there, two person trying to converse. You can also see a music player there. Now, what kind of energy is this now? This is the sound energy here. The very reason how you are able to listen to me and listen to my lesson right now is because of this sound energy there. What does it do? Sound energy enables us to converse. It enables us to communicate. It enables us to hear, without which it wouldn't have been possible for us to communicate with other people had there not been sound energy. Okay? Now to sum up, let's look what we have here. So what do you see there? Power is the rate of doing work. The rate of doing work is power. And how are we able to do our work? We are able to perform our work because of the energy. Without energy, we wouldn't be able to do any kind of works. Energy is very important to do work, and at what rate we do this work is termed as power. I hope this helps you recollect everything whatever we have studied until now. To save your boredom, I'm here to your rescue. Explore the forms of energy in the given activities. Now what I want you all to do is use your detective mind here now. Try to explore the different forms of energy that is involved in the given activities. What are the activities? Lighting up a table lamp. When you put on the table lamp, what forms of energies are involved there? It is not just one. Second, bouncing a ping pong ball on the table. That means when you are bouncing your table tennis ball on the table, what forms of energies are there? Please think carefully. When you drink a sip of juice, when you are enjoying a sip of juice there, what energies are involved there? Did you ever think about this one? No, isn't it? You just enjoy the taste of the juice. But now, try to find out what forms of energies are involved there. Next, what could be the energy of a flying Druk Air, our very own aeroplane? So when it takes off or flies in the atmosphere, what forms of energies are involved there? Please try to find that out. And finally, is work the same as power? What do you think? Are these two same? Please find that out. And with this, I thank you all for listening to me. Wash your hands. Be safe. Thank you.